Hello, students. All right, welcome to our lab activity with weather. Yes, today we are going to be playing around with an instrument called a psychrometer to measure the humidity in the air of this room. Before we do, let's just get over to our notes here really quick to finish up this last word, which is psychrometer. The psychrometer is an instrument used to measure humidity or water vapor. Now, there are different kinds of psychrometers. I'll be showing you in the lab how we use this psychrometer. You in the lab are going to be using this psychrometer, but you'll notice in both cases, let me show you the basic parts to a psychrometer. I'll show you the diagram here first. Oops, wrong button. Let me show you the diagram here first. There is a psychrometer is made up of two thermometers, one that is a dry bulb thermometer and one that is a wet bulb thermometer. And then there's on this one, there's what's called a slide rule. In our lab, we can see on our lab page, there is a chart there for you to use to actually make the calculation. You're only going to do one simple subtraction problem, and the rest is all calibrated for you in this table. But here's the deal. If you look at this psychrometer here, this is the dry bulb thermometer on this side, and it's just a regular thermometer in degrees Celsius. And the wet bulb thermometer on the other side. They're both identical thermometers. The only difference is the wet bulb thermometer has a piece of cloth around it, and you're going to dip that into water. Why? Well, let me show you this one here as well. Here's another psychrometer, two identical thermometers, but one is dry and one has a cloth around it to be the wet one. Let me ask you a question first. How many of you have ever gone swimming? How many of you ever got out of the water, you were dripping wet, and noticed you were a little bit colder? Same thing with taking a shower or a bath. When you get your body wet and you're in the water, you feel fine. As soon as you get out of the water, whoa, you feel a lot colder. There's a reason for that. The reason for that is the same reason as why your body sweats. When you are hot, you sweat. Why? Because it gets your skin wet. Well, what does that mean? Well, when moisture evaporates off your body, it lowers your temperature. When we get to physical science, we'll understand that a little bit better. But for now, know that when you are wet and you're hot, that moisture evaporates and it cools you down. Well, think of a psychrometer. One side is dry, one side is wet. When you start spinning the psychrometer around during the lab, the dry side is simply going to be measuring the actual air temperature in the room. The wet side, however, just like if you come out of a wet swimming pool and you're wet and the wind is blowing over your body, ooh, you get goosebumps because you get colder and colder. What do you think is going to happen to the temperature of the wet bulb side? Do you think it's going to be higher or lower than the dry side? Hopefully you guessed colder, because that's exactly what happens. So what you're going to be doing in the lab is this. You're going to have a psychrometer, and you're going to take this psychrometer and you're going to dip it in water. The cloth will absorb the water on the wet bulb side, and the other side will just remain dry. We're going to do it all together, but you're going to record those temperatures. You're going to record the dry temperature, and then you're going to swing the psychrometer around for about 30 seconds. Now, as you're spinning it around, the air is flowing over both sides. The wet bulb side is going to get cooler. You're going to record how much cooler the temperature goes down, because there is a direct relationship between how much moisture is in the air and how much more moisture can fit in the air and what the temperature is. So what you're going to be doing is using this chart to measure the dry bulb temperature in degrees Celsius. Then you're going to see how much the temperature went down with the wet bulb. And you're going to use that number here. And just like Battleship, wherever those numbers intersect, you don't have to worry about making the calculation. This chart has already done it for you. But the number that you arrive at will be the relative humidity in percent of the classroom air that we are in. So again, what you're going to be doing is measuring the temperature on the Celsius side, and we're only using Celsius thermometers in the lab this year. So that's a good thing. You don't have to worry about the difference between Fahrenheit and Celsius. But you're going to be swinging the psychrometer for about 30 seconds, looking at both the dry bulb and the wet bulb temperatures. You're going to record that information in your book under your observation section. You're going to record that information and then use that information in this chart to calculate. So before you get started, I want you to write a hypothesis, if you haven't done so already, to the following question. What is the percentage of humidity, or the amount of moisture, in the classroom's air? I'll give you some guide points here. If it was 100% humidity, it would be raining in here. If it was 0% humidity, you'd all be dying for a drink of water. So you know it's somewhere between 0 and 100%. It's up to you to make an educated guess. What do you think the humidity in the air in this classroom is? Take a moment, write your hypothesis if you haven't already. You can pause the video. All right, welcome back. You have a prediction of somewhere between 0 and 100% humidity in the classroom air. Now, if you're actually in the classroom, we're going to do this in real life. If you're not here for whatever reason, if you're watching from home, let me just give you the information, okay? After spinning for 30 seconds, the dry bulb temperature was 20 degrees Celsius. The wet bulb thermometer temperature was 12 degrees Celsius. Using that information, look at your observation section. The wet bulb depression is just the difference between those two numbers, so simply subtract. Write that number down, and that that difference between the wet and dry bulb, that wet bulb depression, is the number at the top of the chart here. Your dry bulb temperature is the number on the left of the chart. Circle those two numbers, whatever they might be, and then find where they join one another on the chart, taking the top number and the side number. Where do those numbers intersect? And you'll come to a certain number on your chart, which will tell you the answer, the relative humidity of the classroom air. So I hope you were able to do that at home. Unfortunately, we'll have a lot more fun actually doing it here in school with our psychrometers. I mean, you could try this at home, but I wouldn't want you swinging glass thermometers around your house. That might end in disaster. So just use the numbers that I gave you here for the video. But once you've gathered your info, see how close you got to your prediction, write your conclusion, and then you've got the remainder of the period to study and prepare for tomorrow's quiz. So on that happy note, I'll say now, for now, bye-bye.